All right, projectiles review. Number 1, which of the following would not be considered a projectile? So in order for an object to be considered a projectile, it must be traveling through the air. The only one in here that is not traveling through the air is C, the cannonball rolling down the hill. Therefore, C is not a projectile. Answer choice A, the cannonball is thrown through the air. It's moving through the air. Cannonball dropped from an airplane. If it's falling from an airplane, it's traveling through the air. Cannonball falls off a table. If it falls off a table, it's traveling through air until it hits the ground. A, B, and D are projectiles. C is not a projectile. Number 2, at the instant a ball is thrown horizontally with a large force, an identical ball is dropped from the same height. We saw this with the tennis ball being dropped and pushed horizontally. We saw this with the bullet being fired horizontally and bullet being dropped. They will both land at the same time because horizontal and vertical motion are independent. Gravity does not affect anything moving horizontally. It only affects an object falling vertically. So they will both land at the same time. Number 3, ignoring air resistance, increasing your projectile speed in the vertical direction. So if I know that my horizontal and vertical motion are independent, it doesn't matter what's happening vertically, my horizontal motion is unaffected. So even if I increase the speed vertically, horizontally, nothing changes. Okay, it has no effect on horizontal speed. They are independent of each other. And number 4, a projectile with a mass of 100 grams and another projectile with a mass of 200 grams are fired from the same height with identical initial velocities. Which two projectiles will hit the ground the same at first? So this is the same concept. The mass of this object is not going to change the amount of gravity that's being pulled or affected on it. They are both going to hit the ground at the same time because mass does not matter. Mass has no relevance in its projectile motion. It's going to fall at the same rate as what would be falling with a lighter mass. At what angle should the ball be hit to provide the travel the furthest horizontally? So I want to travel the furthest horizontally, the furthest horizontal distance, and in order to achieve the greatest horizontal distance, I must aim it at 45 degrees. Okay. Number 6, in the Shoot the Monkey video, why is it important why is the air gun aimed directly at the monkey? Well, at the same time the monkey falls down, the bullet is being shot. They're both being pulled down by gravity. So the bullet and the monkey are both falling at the same rate, which is why the gun needs to be pointed at the monkey. All right. Numbers 7 through 10 are referring to the same scenario. It says Letty's standing on a cliff above sharks, water, and sharp rocks below. She's kicked off a cliff with a horizontal velocity of 7. She reaches a vertical speed of 50 before hitting the water. So here's Letty. She's kicked off a cliff. She's following this parabolic pathway. She has an initial horizontal velocity of 7. And vertically, right before she enters the water, she's traveling 50 meters per second down, which is represented as a negative 50. Okay. Now, a few other things that I already know that are implied. Well, I know that gravity is still negative 9.8. And I know her initial velocity at the top is 0. Okay, so these are things that I know. Now, I want to know, according to number 1, I want to know how long it's going to take her. So how long is referring to time. So time is unknown. Okay, so let's look at what I have. I have the acceleration of gravity. I have the initial vertical velocity. I have horizontal velocity and final vertical velocity. If I want to know how long it's going to take, if I want to know time, I can't use my horizontal equation because I don't know dx. So it's got to be a vertical equation. I know VF, I know VI, I know A, I want to solve for T. So my equation is going to be A equals VF minus VI divided by T. So A equals VF minus VI divided by t, where a is a negative 9.8, VF is a negative 50, VI is 0, and time is unknown. So now I want to set up a fraction so that I can cross multiply. Negative 9.8 times t and 1 times a negative 50. This minus 0 goes away. Okay, it's not going to affect my problem here. So negative 9.8 times t is negative 9.8 t, and 1 times a negative 50 is a negative 50. Now again, I want to get t by itself, but it's being multiplied by a negative 9.8. So the opposite is to divide by a negative 9.8 on both sides. And when I do that, the 9.8's cancel, and I have t by itself. And on the right here, I have negative 50 divided by a negative 9.8. That gives me 5.10 seconds. Okay, so the time it took was 5.10 seconds. How high above the water was she when she was kicked? So how high is referring to vertical distance. Okay, so this is dy. Okay, so I want to look at how far vertically up and down she falls. Well, if I want to know a vertical distance, that's a vertical equation, so it has to have a. So it's got to be one of my equations that include negative 9.8. I know the initial velocity. I know the final velocity. I want to solve for vertical distance, and I know a. The equation that I'm going to use that is going to be best for this would be a equals VF squared minus VI squared divided by 2D, where a is a negative 9.8, VF, that's a negative 50 squared, minus 0 squared divided by 2 times d, we don't know. So if I set up my fraction on the left so I can cross multiply, got divided by 1. Now, 0 squared is 0, so I don't need any of this, goes away. Okay, so I have negative 50 squared. Now I can cross multiply negative 9.8 times 2d and 1 times a negative 50 squared. Well, negative 9.8 times 2d is a negative 19.6. d equals, and then 1 times a negative 50 squared, that is 2,500. Okay, last step is to get d by itself. And in order to do that, I got to divide by negative 19.6 on both sides. These cancel out, and d is all by itself. And that displacement is, if I take 2,500 and I divide it by negative 19.6, I get 127.55 meters. Now this is a negative displacement, but if you're asked to solve for height, I would write this as a positive 127.55. Okay, number 9, how far away from the cliff will she land? So now I want to know how far horizontally she landed. I already know how high she is, vertical distance. I want to know how far horizontally. So now I want to solve for dx. How far away is referring to dx. Okay, and there's only one dx equation, and it is Vx equals dx divided by t, where my horizontal velocity was given to me in the problem. It is 7. Dx I do not know, and my time we calculated in number 8, which is 5.10. So now I need to cross multiply 7 times 5.1 and 1 times dx. 7 times 5.1 gives me 35.7 meters. 1 times dx is dx. So horizontally, she will land 35.7 meters away. And the last one here, number 10, what would be the resultant velocity? So resultant velocity is how fast she's moving at an angle. So not true vertical or true horizontal. It's moving at that angle, combining those two velocities. So the resultant velocity is VR. Okay, and VR is equal to horizontal velocity squared plus vertical velocity squared, all under the square root. Well, my horizontal velocity was given to me, and that was 7. My vertical velocity I solved for it was given to me, and it's 50 meters per second downward, so a negative 50 squared. Okay, so negative 50 squared is 2,500. 7 squared is 49, so you end up with the square root of 2549, which gives you 50 point, let me check my math on that one, 0.49 meters per second. Now it's in a downward direction, which means my velocity needs a negative. So negative 50.49 meters per second. Okay, so that's the front page. Front page is done. Next page. All right, so now I have Carlos is serving a tennis ball. He strikes the ball while it's 2 meters above the ground. So it's telling us basically the vertical distance. The ball travels 25 meters forward, striking the ground. So now it's telling us how far forward it travels. That's a horizontal distance of 25 meters. I want to know how long it's going to take to hit the ground, how fast it's moving horizontally, and how fast it's moving vertically. So let's start with how long it's going to take. So how long is referring to time. I want to know how much time does it take to hit the ground. So here, t is unknown. Okay, now some other things that I know that aren't given to me. I know A is still negative 9.8. And I know the initial velocity at the top of its path is 0. Okay, so how long will it take? Well, I know the vertical distance. I know the horizontal distance. I don't know the horizontal velocity, so I can't use that equation. I do know A, I know VI, I know D, I can solve for T. So remember that rearranged equation. If I know the vertical distance and I want to solve for time, I can use the rearranged equation we talked about in class. So T equals 2 times dy divided by A, all under the square root. So 2 times my dy was also 2 divided by 9.8. So I'm going to write this as a positive 9.8 because you can't take the square root of a negative and time has to be positive either way. So 2 times 2 is 4, 4 divided by 9.8, and then taking the square root of that answer should give us 0.64 seconds. So it takes 0.64 seconds to reach the ground. Now we want to know how fast horizontally. So this is given or asking me for a horizontal velocity. Well, there's only one equation for horizontal velocity, and it's dx divided by t, where my horizontal distance was 25 meters. My time we just solved for is 0.64. 25 divided by 0.64 gives you 39.06 meters per second. That's how fast it was traveling horizontally before it hits the ground. Okay, now instead of how fast horizontally, I want to know how fast vertically. That's a vertical velocity. In other words, this is asking for final velocity. Final velocity is unknown. Well, if I look back at everything I do know, I know VI, I know A, and I know D. Okay, I also know time. However, there's a chance that this might be rounded. There's a chance that this could be incorrect. I'm going to use my equation that does not include time. It includes D. So I'm going to use A equals VF squared minus VI squared divided by 2D. Where A is a negative 9.8, VF I don't know, VI is 0, and D is 2. Okay, so let's set up my fraction so that I may cross multiply. Okay, before I do that, I know that 0 squared is 0, so I'm going to ignore all that. And I know that 2 times 2 is 4, so I'm going to rewrite that 4 in there. Okay, so now I can cross multiply. Negative 9.8 times 4 and 1 times VF squared. So negative 9.8 times 4 gives me a negative 39.2. And 1 times VF squared is VF squared. My next step is to take the square root of both sides to get VF by itself. Remember, you can't take the square root of a negative, so make it positive. And the square root of a positive 39.2 is 6.26 meters per second. And that's in a downward direction, so I need to put the negative back on there. Okay, that's it for that problem. Now looking down here below. Cannonballs fired vertically 40 meters per second out of the bed of a truck, traveling forward at a speed of 30 meters per second. So what you're looking at is a truck traveling horizontally at 30, and it's going to fire a cannon vertically at 40, and it's following this pathway here. Okay, so we're going to have to answer some information about what's going on at the initial point from the truck, what's going on at point A or position A, what's going on at B, and what's happening at C. Okay, so to understand this a little bit more, we need to know what the shape of this path is called, and this is called a parabola. Okay, that curved pathway is a parabola. Relative to the truck, where's the cannonball going to land? Well, because that cannonball has horizontal velocity, its inertia is going to allow it to go up, all while the truck is moving horizontally. They will maintain the same velocity. The cannonball will land back inside the truck. Okay, back inside the truck where it started. All right, last few. So I want to complete this chart. So this is a little bit different than what you see on your review. However, the only thing that's different is the information from the truck. So this is going to be a little extra information. I'm still going to work through this stuff because it's still stuff that you need to know. Just know this part is not going to be on your review. So if you're lost, you don't understand what's going on, this is why. This part right here, this area from the truck is not on the review. Position A, B, and C is. So the rearrangement is a little bit different. So you need to find the horizontal velocity, distance, time, and so forth at each position and fill them in accordingly. Okay, so I'm looking at from the truck. I want to know the horizontal velocity from the truck. Well, that tells me right here it's 30. So I'm going to fill in 30. I'm going to zoom in a little bit. This is 30 meters per second. Okay, horizontal distance from the truck. It hasn't traveled at all. Okay, so I'm going to mark through that. The horizontal acceleration. I know the horizontal velocity of that ball is going to be constant. Therefore, it does not have any horizontal acceleration. It's not speeding up, it's not slowing down, it's not changing direction. It is 0. Let's see, the time it takes from the truck, well, that's where our time starts, so that is also 0 seconds. Vertical velocity. It shows me in that truck that the vertical velocity is 40. So 40 meters per second is my initial velocity at the truck. Okay, vertical distance. At that point, it doesn't have any vertical distance. Okay, the acceleration, the vertical acceleration, that I do know. That is a negative 9.8. And the resultant velocity at that point. Okay, so that I can calculate. So VR is Vx squared plus Vy squared, all under the square root. If I look back at my diagram, I notice that my horizontal velocity was 30. My vertical velocity is 40. So 30 squared plus 40 squared, all under the square root. So my resultant velocity is the square root of 2,500, and that is 50. So my resultant velocity at the beginning of the path is 50 meters per second. Okay, at the top, well, I know that the horizontal velocity stays constant. So I know at the top it's going to be 30, partway down it's going to be 30, at the end it's going to be 30. That does not change. So I'm going to go ahead and fill those in because I already know those. So this is 30, this is 30, and this last one is 30. Okay, my horizontal distance at the top. Actually, I'm just going to go ahead and fill out, for the sake of time, I'm going to fill out the information that you have on your review. So at the top, at point A, the acceleration of gravity is something that you're asked to find, and that is negative 9.8. Okay, so the acceleration of gravity, A, is negative 9.8. I also know, let's see, the horizontal velocity, I just wrote that in there. I know that is 30. The vertical velocity at the top, it's no longer going up. It has yet to come back down. Its vertical velocity at that highest point is 0. And its resultant velocity, well, if you think about this, it has 30 meters per second horizontally, no vertical velocity. So if I add these together, I get 30 plus 0 is 30. If I square 30 and then take the square root, I'm back where I started. So the only velocity that I have at that highest point is the horizontal velocity, and that is 30 meters per second. Okay, now at point B, we already said that the horizontal velocity was 30. That does not change. At point B, I know the acceleration of gravity is still a negative 9.8. And that's really all that I want to calculate at point B. At point C, I know that the horizontal velocity is still 30. I know the acceleration of gravity is going to be constant at negative 9.8. Okay. The vertical velocity, well, remember that the right side of this parabola mirrors the left side of this parabola. So if at this position I have a positive 40 meters per second, then at the same position on the opposite side, I'm going to have 40 meters per second downward. So that vertical velocity, that final vertical velocity, is going to be a negative 40. So my Vy all the way over here at point C, I'm going to have a negative 40. And the resultant velocity. Well, I mentioned before that the parabola is basically a mirror of itself. So whatever's happening on this side is happening on this side, and vice versa. Well, if my resultant velocity at this position was a positive 50, then at the same position on the opposite side, I have the same velocity, but in a negative direction. So I don't even need to calculate that. I know that that resultant velocity is going to be a negative 50 meters per second. Okay, so all we did was we went through and we filled out all the information that you have on your review. I know this looks a little bit different, but as long as you fill in all the values that here on the right that pertain to A, B, and C, then that's all I'm really concerned about. So all the information that's in between, is not going to be calculated. So you don't have to worry about any of this stuff right here. Okay, so I hope you're able to study. I hope you're able to follow along. Remember, our test is Wednesday. If you need me, you may send me a remind. I'm going to post this video on my Google Classroom for future references, so don't forget how to get to this point. If you have any questions before class, come see me.